So it's no real capacity level to the ECF?
No. It's going to, if all those other controls that were present, the local control, the autonomic nervous, the hormonal, they're going to all work to try to keep it balanced. So, for example, aldosterone, which would be the salt retaining, it could actually help these tissues retain salt, and if not present, help them get rid of it. So under normal conditions, okay, in situations like this, they are working normally. All those controls are working normally so that we have proper balance at this capillary exchange. Does that make sense? So if this one's 0.7, if this one's 0.7, and that's how the situation is in those tissues, we're good. If this one were at 0.5, this one's at 0.7, this would begin to lose water to build up in those tissues.
What is their reaction of vomiting? Like whenever, sometimes I think if you can become dehydrated, don't you?
Well, in cases of severe vomiting, yes, what's happening is all those, as you continue to, like, usually vomiting, a lot of it, you know, in the beginning is done because something is in the body that it wants to get rid of, okay? But in cases where you're going to be sick and it continues, it's got to pull fluid from somewhere, or you begin literally throwing up the lining of your stomach, which means you begin to throw up bile. Bile is from other areas of the body, wants to still make it, so it's trying to pull it to make it, but at the same time you're throwing it up, so your cells are going to get dehydrated.
I mean, like from dehydration. Isn't that something like when somebody is dehydrated and they can do that? So then why does the body want to like pull it?
Well, wait a minute. When somebody's already dehydrated,
yeah,
and they begin to throw up.
That's what I was told from somebody before. It was like that they were like getting sick and they were severely dehydrated, but it was like overnight or something. But they weren't dehydrated from
throwing up. They were dehydrated.
They were dehydrated, and that was.
Was there another reason for the dehydration? Were they just not drinking what they need, or were they having diarrhea?
No, it was just that. I don't think that they were
just not drinking enough, and then they started. Did they have anything to throw up, or did they begin to start throwing up bile?
They started becoming that.
Okay, started throwing up the bile. And then that's where it becomes so severe, because that's where it's pulling from other areas of the body to try to keep something there.
Yeah.
And then that's where they're like, oh, well, you'll start throwing up the lining of your stomach. And really, that's all the bile and everything being pulled. That should be coating and keeping that stomach environment ready for food, for the acid that's going to be released, so that the acid does not eat through the stomach itself. That's what an ulcer is. An ulcer is when that acid has produced so much that it literally eats through the protective lining, i.e. that bile that we think of, to the actual tissue of the stomach itself, and that's when you have an ulcer. Yeah. And sometimes they can be so severe they actually create a hole in that tissue. Yeah. So hopefully they got a IV.
Yeah.
Yeah. Yeah. Probably infused very quickly too. It's kind of a rush. Okay. So that got me way far ahead. Okay. But my goal is making sure, because I want you all to understand this process, okay? Because I have actually had the professors come to me and tell me they did not even know what it meant to be hypertonic or hypotonic, or to be in these situations where there was edema or not, okay? So I want to know, my students know that when they go into their programs, all right? And if y'all go here or well, anywhere, if y'all ever go into those programs and are like, Dr. Burnett, I don't know this, ask me, I'm more than willing to help, okay? So as we look at this exchange, all right, what we need to know is that materials get to move out, materials get to move in, we keep the tissues and the cells happy. So what they have to do, based on the fact that these capillary beds, they are so small, we actually study them based on collections at the ends of our fingernails. And yes, I'm in the process of painting at home, and I still got stuck all in my dry skin and everything, and I can't get it all out. So yeah, I got paint everywhere. They actually study it based on areas that are happening at the base of the nail. And what we find some pressures. Now, you guys remember us talking about millimeters of mercury? We think of that as associated with our blood pressure, right? That 120/80, okay? And do y'all remember how I've kept mentioning that by the time we get to our capillary beds, on that arterial side, pressure is almost non-existent. And on the venous side, like nothing, okay? What we have found is we have that little bit of blood pressure at this capillary end. On the arterial side, and here's my venous, my pressure is about 32 millimeters of mercury. On the venous side, it's roughly about 15. The water, this extracellular fluid that's going to exist, has a pressure. And the pressures that we find, they work, because you know, when we have pressures go up and pressures go down, that will cause the movement of something to occur. So it actually allows on the arterial end for materials to move out and create a suction almost on the venous end so that the waste can move in. Is that not cool? Based on just that little bit of pressure that is there in those tissues. Now, what do you think would happen if somebody suffered low blood pressure? Do you think this number would stay 32? No. So what do you think would happen to materials moving out on that arterial end? It's not going to be as great. That means over here, not as great, okay? But what if somebody has high pressures, blood pressures? What do you think is going to happen on this side? This number could increase, okay? And that can actually cause capillaries to burst. For example, when we start talking about the kidneys, the way that the kidneys are going to function, they have this little thing called a nephron. That nephron has, it's a glomerulus. Do y'all remember us mentioning glomerulus? When I told you to always let it make you think of a circle? Okay? So the kidneys on the nephron are going to have a glomerulus. And inside of it is this ball of capillaries. Somebody with high blood pressure, as that blood comes in, and think about how high blood pressure is normal coming into the kidneys, which are right here just off of the aortic arch. Okay? Think about how high blood pressure already is just under normal conditions. You take somebody with high blood pressure and it comes into those kidneys, coming into something that is so microscopic and having that little ball of capillaries and high blood pressure, what do you think it's going to do to those capillaries? Burst them. And this is why people with chronic high blood pressure problems end up with kidney problems. because once that glomerulus, once that ball of capillaries burst, it never repairs. And therefore kidney function gets impaired. So blood pressure problems are a major issue. The chemicals, these materials, okay, they get to pass. Note the difference, okay? One's got pass, one's got movement. The way that they will pass from the capillaries to the tissues, those endothelial cells, okay, because remember, at that capillary level, we are one cell layer thick, all right? So these cells are like that. The cytoplasm of these cells can allow something to move across that cytoplasm, the inner part of the cell. Does everyone remember that? Do you remember the intercellular clefts where it goes between cells? That's one way it can move. And then do you remember the pores that we had? So these are the three ways that materials pass. Their mechanism: diffusion, which we've defined, transcytosis. Transcytosis means something passes from one side of a cell to the other, because trans means to go across, cyte means cell, okay? So something can move across that cell, and then reabsorption, meaning we absorb something once, but now it can turn around and we can absorb it again. We'll see that in the kidney.
I'm sorry, can you repeat transcytosis?
Transcytosis. If you think about a cell, for something to actually go from one side of the cell to the next, that's a long trip, okay? Trust me on that. And trans means to go across, okay? So a particle can actually go from one side of the cell to the next, and it's called transcytosis. Take a break. Be back at 10:30.